Hey everyone, welcome back. This is lesson 10.6, identifying conic sections. Your objectives for today, you're going to be able to identify and transform conic functions, and you'll be able to use the method of completing the square to identify and graph conic sections. All right, here's a chart of standard forms for the conic sections with the center at HK. This is a really important chart and will help you a lot, and we'll be using it a lot in this lesson, and it'll be good for you to get pretty much memorized. So the equation of a circle in standard form looks very much like the distance formula. Notice that the ellipse looks very much like it also. All right, if it's horizontal, that means the major part, this A, is going to be with our X and B with our Y. If it's vertical, that means the A is going to be with our Y. Okay, because A is major, it's going to be vertical, so that means it's going to be a little bit longer on the vertical axis. All right. And then B will be with the X in this case. All right, for the hyperbola, again, it looks very much like what our circle, but again, this time we've got a minus in here, all right, instead of a plus. So the ellipse and the hyperbola both equal to 1. So that's really important to remember. I remember ellipse is plus. So for some reason, I just think of ellipse and kiss, and that's plus. So, and then hyperbola is going to be the minus. Minus my, got that I sound, and high. I just kind of remember both of those. But remember, they both have equal 1. All right. Also, for the hyperbola, if it's on the horizontal axis, the major, again, stays with the X, and the vertex stays with the Y. Again, if it's vertical, the major vertex is going to go with the Y, and the co-vertex will go with our X. And then finally, the parabola is pretty much different from all of them. They're somewhat the same. We see this Y minus K squared, but we don't have our X is not squared in this case, or in this case, our Y is not squared. So here is all 4 equations in standard form. Do yourself a favor to learn them all as much as you can. All right, next. Okay, so here we have an example. It says to identify the conic sections in standard form. And so we're going to look at this equation, and the first thing I see is I have 1x, but my y is squared. So that's going to tell me right away the equation is the same form as the parabola, all right, with a horizontal axis of symmetry. So in this case, x is going to equal y squared. So that tells us it's going to be opening horizontally. All right, when I look at this one, I see that it equals 1, okay? And so that helps me, and I see a minus sign. So those are 2 clues that this equation is in the same form as the hyperbola. All right, high minus, and there's my minus, so it's in the form of a hyperbola. When I look to see if it's a horizontal transverse axis, I'm going to look for my major, and the major one actually is my X, because the X comes first this time. All right, so remember, it's going to actually look like this. So it's the same as a hyperbola with a horizontal transverse. All right, let's try another. The last one, I see that I don't have any denominators here, no fractions or anything. So I remember that this conic section is the same as a circle. So this is going to be my distance, and this will equal my radius squared. All right, your turn to try it. Turn the video off and see if you can get these on your own. All right, so on this one, it looks a little bit different than what I'm used to seeing. I've got an x squared and an y plus 14 squared equals 11 squared. So let's see what that could possibly be. It's the same as a circle. The only thing that might have thrown you off is that this didn't have anything. So that's actually an understood x minus 0. So that tells me the circle on this, the equation, the center of this circle is going to be at 0, comma, negative 14. All right, and it's going to have a radius of 11. All right. On the second one, I see again that it ends in 1, and I've got a minus here, so a minus, hi, my. That should give you a hint. The equation is the same form of a hyperbola with a vertical transverse axis. How did I know it's vertical transverse axis? Well, I looked at my first piece here. The y, remember the y's are going to look like this, kind of like a y. And so I know that that's a vertical transverse axis right here. All conic sections can be written in the general form ax squared plus bxy plus cy squared plus dx plus ey plus f. All right, so the conic section can be represented by an equation in general form, can be determined by the coefficients. So remember, these are our coefficients, A, B, C, D, E, and F. All right, I'd like to remind you of our song that we sang a while back in the chapter on the quadratic equations. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, I hope you remember that. And we're going to use this part. Notice b squared minus 4ac. B squared minus 4ac. We're going to take a look at that, and depending on what it equals, we're going to be able to determine whether we have a circle, an ellipse, a hyperbola, or a parabola. All right, so we're just looking at this b squared minus 4ac. So for number 1, if it's a circle, let's see what happens when we fill in A, B, and C. We're just going to really be interested in this short little section right here, the A, B, and C of that. So the ax squared, bxy, and cy squared. That's our main things that we're going to be concerned about. So if b squared minus 4ac is less than 0 and b equals 0 and a is the same as c, a equals c. If that is true, you have a circle. All right. If b squared minus 4ac is less than 0 and neither b is equal to 0 or a is not equal to c, then we're going to have an ellipse. If b squared minus 4ac is greater than 0, it's going to be a hyperbola. And if b squared minus 4ac is equal to 0, it's a parabola. All right, so what I would do to remember these little things, I would just remember if it's bigger than 0, I think this hyperbola one is pretty easy. If it's bigger than 0, I think of being hyper as being bigger than active, more active. So if it's greater than 0, it's going to be bigger, so it's going to be a hyperbola. If it's equal, it's going to be a parabola. I don't know how, just have to kind of remember the parabola is equal. The circle, it just has some conditions in it, and so if it's less than, it's either the circle or the ellipse. And the circle A has to equal C, and B has to be 0. So if those things are true, then it's a circle. If they're not, it's the ellipse. So we're going to work with that, and hopefully you'll get that down for memory a little bit better too. All right, so let's take a look at an example and how we're going to do this. It says identify the conic section that the equation represents. So remember what we're going to look at. The first thing we want to do is identify the values for A, B, and C. So we have to look at what our original formula, ax squared, bxy, and cy squared. That's all we're going to worry about. And we already have that. So our A is 4. Our b is negative 10, and our c is 5. Now we're going to put it into that b squared minus 4ac format. There it is. And we're just going to substitute all of our letters for that. And we end up, when we simplify, we end up with 20. So b squared minus 4ac is equal to 20, and that is greater than 0. So we're going to come up here and look at our chart for things that are greater than 0, and I see that a hyperbola is the only one that is greater than 0. So your answer is, because it's greater than 0, the equation represents a hyperbola. All right, try another one. So first of all, let's get our chart pulled up here. All right, the first thing that we want to do is go ahead and identify our values for A, B, and C. So as you can see, A is 9, B is negative 12, and C is 4. So here's our equation, B squared minus 4AC. Now that we know that, we can just go ahead and substitute our A, B, and C into it. And when we do, we end up, after we simplify, we end up with 0. All right, so here we have our B squared minus 4AC equals 0. And when it equals 0, we can see that it is a parabola. Because it equals 0, the equation represents a parabola. All right, let's try another one. So again, let's pull up our chart to look at it for right now. The first thing we want to do is identify A, B, and C. So I can see an A, a B, and a C. And there they are. So remember, B squared minus 4AC. Go ahead and substitute. And when we do, then we simplify. And we get 33. So B squared minus 4AC is equal to 33, which is greater than 0. Okay, so we're at a greater than 0, so that must tell us that we're working with a hyperbola. All right, the equation represents a hyperbola. All right, time for you to try one on your own. Turn the video off and give this one a try. Here's your chart. Okay, so first thing we do is identify our A, B, and C. So A is 9, B is 0, and C is 9. So let's see why that is. We got a little bit tricked. I hope you didn't. It says x squared and a y squared, but we don't have our b, x, y in here. So b actually equals 0. So I wonder if that tricked you. All right, so now that we know that, and our c is 9, and so now that we know that, now we're going to substitute into our b squared minus 4ac, and when we substitute, we end up getting negative 324. Well, that is less than 0, so I know I'm either looking at a circle or an ellipse. So now I have to look at my conditions. Does A equal C? Yes, A does equal C. Does B equal 0? Yes, it does. So that tells us that this is the equation represents a circle. All right, here we go. Try another one on your own. There's your chart. All right, once again, taking a look at this, the first thing I want to do is identify my A, B, and C. I do have a B this time, and there's all my points. B squared minus 4AC, substituting in for it. I'm going to, once I finish all that and simplify, I get 0. So it equals 0, so we only have one choice. We don't even have to think about it. It's going to be a parabola. All right, if you're given the equation of a conic in standard form, you can write the equation in general form by expanding the binomials. If you are given the general form of a conic section, you can use this method of completing the square. Now, we've done this before in the past, completing the square from lesson 5.4 to write the equation in standard form. So let's try some. But first, remember, you must factor out the leading coefficient of x squared and y squared before you can complete the square. We'll remember that as we do it. All right, so let's give it a try. We're going to find the standard form of the equation by completing the square, and then we're going to identify and graph each conic. All right, so how are we going to complete the square? Well, let's rearrange our letters so that we can do this. So we're going to do, let's say, x squared plus 8x plus something plus y squared plus a negative 10y plus something is going to equal, and let's go ahead and add 8 to both sides, plus 8, so it's going to equal 8. All right, so what are we going to put in these somethings? Okay, we're going to have, here we're going to have an x, and here we're going to have our y, and we want those to be squared so we can fit it into our formula. So how do I complete the square? Remember, we're going to take this x, divide it by 2, and then we're going to square that. So 8 divided by 2 is 4. 4 squared is 16. All right, so if I add 16 here, I need to also add 16 on the other side to keep my equation balanced. Now I can look at this little piece right here, x squared plus 8x plus 16, and write that as a perfect square. Well, two numbers that multiply together to get 16, add together to get 8 are 4 and 4. So I know that's going to be x plus 4 times x plus 4. Or I could rewrite it, x plus 4 squared. Now I'm starting to get into an equation that I recognize. All right, let's complete the square with the y's. So again, we're going to take my 10, negative 10, divide it by 2 equals negative 5. Negative 5 squared equals 25. So I'm going to add 25 here, and if I add 25 on this side, I have to add 25 onto the other side. So now, two numbers that multiply together to get negative 10 are going to be negative 5, and they'll add together to get 25. So here we have y minus 5 times y minus 5, or y minus 5 squared. So now our equation is starting to look like something that we can actually identify. So next, 24 plus 25 is 49. All right, so here we're ready so far. We have x plus 4 squared plus y minus 5 squared equals 49. So let's move on to the next slide. Okay, here it is written out for you. It's factored, and now that we look at this, we can recognize this as a circle. So this is the exact formula of a circle, and 49 is our radius squared. So the square root of 49 is 7. That means tells us that we have a radius of 7. I also know that my center is going to be 4, actually negative 4, 5. So that's where our center is. And then you could graph this. Just find your center at negative 4, 5. Negative 4, let's see, 2, 4, 1, 2, okay, there it is. And a radius of 7, and there it is. This example is the same thing, but it's a little more complicated. So again, we want to find the standard form of the equation by completing the square. So the first thing I want to do is go ahead and set my equation up so I'm ready to complete the square. So I'm going to set it up, 5x squared plus 30x plus something plus 20y squared plus 40y plus something, and that's going to equal, I'm going to move my negative 15 over here, positive 15. All right, so I don't like having a number as my leading coefficient for my x squared, so I'm going to actually factor out a 5. So I'm going to factor that out, and that's going to leave me with x squared plus 6x plus something. All right, now what is that going to be? Well, I take my 6 divided by 2, that gives me 3. 3 squared equals 9. So I'm going to add 9 to this side, but notice that I factored a 5 out, so I actually added 45. All right, so I'm going to have to add 45 over to the other side of my equation here, because 9 times 5 is 45, and that's actually what I did. All right, so now I can complete my square here. Now that I have it completed, I can say 5 times x plus 3 times x plus 3, which is the same as 5 times x plus 3 squared. All right, now we're going to do the same thing for the y's. Again, I have a 20 here, and I really would like that to be 1, and I see that I can actually factor a 20 out. So that's going to leave me y squared plus 2y plus something. All right, and now it's actually equaling 60. So let's see what that something is. Well, we take our 2 and divide by 2. 2 divided by 2 equals 1, and 1 squared is 1. Okay, so I added 1 here, but I actually added 20 times 1. I actually added 20, so I'm going to have to add 20 to this side also. So I end up with, and I'm just going to write it out the way it should be, 20 times y plus 1 squared. And that's going to all equal 60 plus 20 is 80. Okay, now that I have that, I'm really close to an equation that looks like one of our circle, ellipse, parabola, hyperbola, something like that. But this, I've got these numbers 5 and a 20 here, and I actually have an 80 here. So what I want to do is I'm going to go ahead and divide everything by 80. All right. And when I do that, the 80 turns to 1, and that looks like something we've been working with. 20 divided by 80 is actually 1 over 4. So I have y plus 1 squared over 4. And I know that 4 is actually the same as 2 squared. So that's helpful. Plus, I have 1 and 16. So I have x plus 3 squared over 16, and I know 16 is actually 4 squared. So now I have something that looks very, very familiar to me. It actually looks like our equation for a, what is it? It's got a plus here and it equals 1. So it must be, drum roll. All right, here's our equation. It is actually in the form of an ellipse, okay, because we've got plus and it equals 1. So now to graph it, I have already graphed it for you, but notice that my center is going to be at 3, -1. So 1, 2, 3, -1 right here, okay. My, this is ellipse, so my major axis is on the x, and that is going to be 4 squared. So I just go 4 over 1, 2, 3, 4, and 4 to the other side. And there it is. And my minor is with the y, so that's 1, 2, and 1, 2. And there is your equation and your circle. All right, try this one on your own. Turn your video off and give it a try. Okay, the first thing I hope that you noticed when you were just looking at this equation, that there is no x squared, there's only a y squared. So that gives me a clue that it's probably going to be a parabola. And we know that the equation for a parabola is x equals 1 over 4p times y squared. All right, so that's a really good clue for us. And it also gives us a clue of what it's going to look like. So let's see if we can figure this out. So the problem tells us to complete the square. So the first thing we want to do is rearrange so that we can prepare to complete the square. So I went ahead and put y squared plus 16y plus something equals 9x minus 64 plus something. All right, so what is this something going to be that I'm going to add to both sides? Well, half of 16 is going to be, we're going to take 16 divided by 2 and square that. So half of 16 is 8. 8 squared is 64. So I'm actually going to add 64 to both sides. And when I do that, I'm going to factor and simplify, and I end up with y plus 8 squared equals 9x. Now remember, that's not quite our equation. We said our equation equals x equals 1 over 4p y squared. All right, so all I need to do is divide everything by 9, and now it looks really exactly correct. X equals 1 over 9 times y plus 8 squared. So because the conic form is in the form x minus h equals 1 over 4p y minus k squared, it is a parabola with a vertex at 0, -8. All right, because the x had nothing added to it, and then this would be -8. And the p equals 2.25, and it opens to the right. The focus is at 2.25 and -8, and the directrix is x equals -2.25. So how did I know that? Well, I made a graph of it, all right? And so when I did that, I found my center, all right? So I knew that the center was at 0, -8. Now, how do I know that the focus, the P, where my P is? I have no idea. No. I'm joking. All right, to find our P, we know that 4P equals 9. So we say 4P equals 9. Divide both sides by 4, and we get P equals 2.25. Okay, so the P, that means 2 places, 2.25 this way is my directrix, and 2.25 this way is my focus, and that's how I know. So notice it says my directrix is at x equals negative 2.25. All right, so there it is. And then my focus is 2.25, and it's still down here at negative 8. So that's how we found our P and all the rest of the information we needed for that graph. All right, try one more on your own. Turn off the video and give it a try. Okay, so here we go. The first thing you want to do is we're going to try and complete the square. So we're going to rearrange everything so that we can do that. And so first thing I want to do is go ahead and try and get rid of these 16. See if I can get rid of this number in front of my x squared, because I really don't like that. So when I factor that out, then I just see that I have an 8x. I factored out the 16 here. And I also factored out the 9 out of this side of it, okay? So I have two pieces. My x, I'm going to complete that square. So I factored out a 16 and a 9. I'm going to move on to the next slide where I have more. Okay, so now it's time to complete the squares. All right, and so remember to do that. We're going to say 8 divided by 2 and then square that. So 4 times 4 is 16. 16 times 16 is actually 256. That would be this piece right here. And then completing the square with my y's, 12 divided by 2 is 6. 6 squared is 36. 9 times 36 is 324. All right, so when we simplify that all out and factor everything, I end up with 16 times x minus 4 squared plus 9 times y plus 6 squared equals 144. Now that's not quite in the format that I need to have because I have these numbers here, 16 and 9. So the easiest thing to do, I'm going to go ahead and divide both sides by 144. And when I do, I end up with this lovely equation, and I see that it's a plus and it equals 1. So that should be your clue as to what this is. Because it is in the form of x minus h squared over b squared plus y minus k squared over a squared equals 1. We know that it is an ellipse. We know that the center is at 4, negative 6. And so when we put that 4, negative 6, we go ahead and put that in here. The vertical major axis is a length of 8. So we have to go 8, 2, 4, 6, 8 on both sides. And that tells us where our vertices are. And the co-vertices, because of this, is going to be, we're going to go 3. The axis length is going to be 3, 1, 2, 3, or 6, actually 2, 4, 6. And circle it up, and there you go. You can see where everything is. And that is the end of our lesson 10.6, identifying conic sections. All right, I hope you understood it, and I'll see you in class soon. Have a great day. Bye.